we're going to optimize this conjunctive normal form by sandwiching it between two different expressions via implication. Meaning, if this is true, then that'll be true. But also, reverse. It also means that if this is false, then this will be forced to be false. Think of these as sets, and think of the ors as unions and the ands as intersections, and then to make some sense of this. So, what we're going to do, if we can find this situation in such a way that E is actually a subset of one of the terms in the conjunctive normal form, then we're going to be able to simplify this expression as follows. See, E is a superset of this, meaning this is a subset of E. So if you intersect E and something contained in E, you'll get back to the thing that's contained in E. So we can just intersect E on like this with no change to that expression. It should still be the same thing because E intersecting with something inside of itself just gives that thing itself back. So now if E is a subset of one of our terms, this is nice, then because E intersected with that term will just be E itself, meaning that E can actually come through and replace anything that it is a subset of. So our choices for E are simply for choosing what to check and what to guess for E, are simply subsets of our terms. Since these are unions or ors here, we can just take parts of the union, like A or not B, or maybe not B or not C, or something like that. So perhaps we don't know exactly what to pick at first, but we're going to talk about how we can find out. We want to simplify this. We have terms of length 3 and a term of length 2. Let's start with the terms of length 3 and get these smaller. So let's pick something maybe that's unique to the terms of length 3, like A perhaps. And let's just see what happens. If E were A and we set it equal to 0, what would happen? And it may not be enough to just do A. Maybe we need A union with something else, or A or something like not B or not D or not C or something. But for starters, we can actually tell what to pick from just starting somewhere. So just start. A equals 0, and let's see where it takes us. So we come through here. It's kind of like being an empty set now and unioning it on. It does nothing here. So we're left with, we can kind of get rid of that in this term because unioning it on does nothing. So we'd be left with not B or not C right here. Similarly here, we'd be left with not B or not D. And then you have an and. Here, C or D would be left the same. Over here, let's think, not A is 1 or true, which is like everything if you're thinking about sets. And if you union it with anything else that's contained in it, it's just itself again, which is everything. It's just 1. So this term is just 1. But if you and that to anything, you just get you can just ignore this because you just get what it is. So because it's a superset of all of this is all a subset of 1. So if you and on, you're just left with what you have here. So what we can do now is we think, well, wait a minute. We want to see if setting A to be 0 actually forces this to be 0. And if it does, what would happen is that A would actually contain this whole expression as a set. Now, it doesn't look like maybe we're going to get that, at least right away. Maybe we could finagle it and try to um, OR and AND it and distribute a little bit to C, but it doesn't look like it too much to me because we have a not, we have a not B here combined with a not D and a not C, but really we don't have any B's or anything to kind of interact with that to make that 0. So what I'm going to try then, so what I've done is I've set A to be 0, but now let's just keep on going with this expression here. What else could be 0 at minimum to make this whole thing 0? Let's try not B. If not B is equal to 0, then what happens is we have this term becomes not C. This term becomes not D. And then this term is just C or D. Notice that this expression is the negation of this one, and you're ANDing. So of course that would be 0, so we've succeeded. Another way you could see this is you could take this, and because AND distributes over OR, and vice versa even, you could take this and distribute it to the D and to the C individually, but notice what happens. As it distributes to the D, you're going to get a D and not D, which becomes 0. Or when you distribute the other way, you're going to have a not C and C, and so that would also be 0. Either way, we've just forced the whole expression to 0 by assuming that A were 0 and not B is 0. How do we get that as an expression? Well, if we had A or not B equaling 0, think of this as a union. That'll force each part of the union to be 0 as well, or like the empty set. So setting this equal to 0 makes A and not B 0, which we just used to show that the whole expression would be 0. So this being 0 forces that to be 0, which actually means that this expression sits above this one. Or in other words, this implies this one. So this is like a superset, and this is like a subset of this set. So we can replace E precisely with this, which is great, because then what happens is it comes through, and what is E, which is this, A or not B, a subset of? It's a subset of this union, because it's a part of this union, and this one as well. So in other words, both of these terms are replaceable with this. So we can just put in A or not B. So we're doing pretty good on the simplification. Let's try to simplify this other guy over here. So let's kind of see where we're at right now at the moment. What we've done is we replaced all of this with A or not B. Okay. Well, let's think about what we could use to get this. What if we let C be 0 and see what that's going to do for us to try to find another expression, E. Let's just build it up. Maybe C won't be enough, but let's see what would work. We actually already know that C or D would work, C union with D. But I'm looking at sub-expressions here, and I already used an A and a not B, so I'm thinking a C will have to be here, but maybe not with the D, but maybe with something else would give me 0. C union with D being 0, of course, would make this whole thing 0 because you'd be intersecting with the empty set here. But let's just try it and see what we get. So just set C equal to 0 for starters, and we end up getting A or not B. Over here we get D. And over here we end up getting not A or not B. That's because C being 0 is like unioning with an empty set. So you end up getting this. Of course, D being 0 would make this whole thing 0. But with something else, Notice, it should be pretty clear. If not b is 0, then this expression simplifies to a and d and not a, which clearly is 0. So it looks like c being 0 as well as not b being 0 would work. So we could have c or not b being e. And so if we set that equal to 0, that makes the whole expression equal to 0, which means that this definitely contains this whole expression, so we can freely just AND it on. So we can AND it on over here. C, that's an OR, sorry, not B. And we can just AND it on to everything. What is it a subset of? Looks like it's a subset of this, which means it can swallow it. Can replace it. So we have just succeeded in simplifying our expression quite a bit. Let's write out what we have. So we have C or not B, and that's parentheses, and C or D, and A or not B. And we have succeeded in simplifying our conjunctive normal form using sandwich swallowing.